Hello, my little mathematicians. Today, we are going to explore basically everything that you need to know from start to finish when you're given a word problem. How to identify the independent dependent variable, how to graph it on a coordinate plane, how to come up with the equation, everything. Okay, so let's go ahead and get started. If you turn to page E-10. So first off, here's our problem. Susie is riding her bike at 3 miles per hour. Okay. Whenever you see the word per, each, every, that's going to be your rate. Okay. So right here, per, each, every, that's going to be your rate. And your rate is the thing which gets multiplied with your X. And I say the word usually, like I'd say 90% of the time, it's going to be your thing that gets multiplied with X. What's also nice when you see the word per, it even gives you, like, it helps you figure out your independent and dependent variable. So right here, it's always like Y per X. So this is your Y, this is your X. So Y is talking about how far, the miles that you go, and X is talking about the number of hours that Susie's been riding her bike. And then the number itself, 3, that's your rate that's going to get multiplied by the X in your equation. Isn't that so helpful? Okay, so when it says write an equation for how far she went, Y in X hours. So we typically almost always want to write Y equals something X. So what did you do to X in order to get your Y? In this instance, they actually told me, hey, this is your rate. That's what's going to get multiplied with your X. And that's it. It's always going to be Y equals something. Unless they tell you to use another variable, fine, then sure, use what they tell you. But otherwise, it's going to be Y and X. And Y is always your dependent, which depends on what you do to the X. Okay, so right here, they told me the values to plug in for X. They said plug in 0, 1, 2, and 3. So let's go ahead and do that to my equation. Okay. Sorry, excuse me. So again, your Y is talking about the distance, right? So sometimes they'll ask you, hey, can you please specify what the Y is talking about? In this instance, it's talking about the distance in miles. And then your X is talking about the time in hours. So they want you to plug in 0, 1, 2, and 3 to your equation. And your equation, we figured out, is 3x, or 3 times whatever x is. So first off, I'm going to plug in a 0 for x. Then I'm going to plug in a 1 for x, then a 2 for x, and then a 3 for x. And what do I get? Well, 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. And 3 times 3 is 9, which means when she first starts, she hasn't gone anywhere. After 1 hour, she's gone 3 miles. After 2 hours, she's gone 6 miles. After 3 hours, she's gone 9 miles. Okay, so that's how I fill out my table. If you were typing in the answer for these blanks, you would type 0, 3, 6, 9. And this is my work of how I got those answers. All I did is I substituted in the numbers they told me to for x into my equation of 3 times x. Once we completed our chart, we want to graph the information on the chart onto the coordinate plane over here. And you connect the points. And then they ask you, like, hey, what shape do the points make? Why do you think that is? So first of all, let's just graph the information. Okay. So, what's what? Well, along this axis right here, if they ask you to label the axes, this is the y-axis. And what's y talking about? The distance. So I would maybe turn my paper sideways and label it that this is the number of miles, or the distance. That's what the y-axis was talking about. So if they say label the two axes, we know that this is the y-axis. I want to know, what was it talking about? It was talking about the number of miles. And the x-axis is talking about what? The number of hours or time. Now I can go ahead and graph. So I'm going to go over nothing, up nothing, right there. Over 1, up 3. Over 2, up 6. Over 3, up 9. Because remember, the x-axis tells you right or left, and the y-axis tells you up or down. If it's positive, you go to the right. If the y value is positive, you go up. So I always, since they're all positive, I went right and then up, right and then up, right and then up, right and then up, whatever numbers it told me. Okay, so I went ahead and graphed them. Now it wants me to connect them. So I connect all my points. And what shape does that make? Well, that shape makes a straight line. Why do you think that is? The reason it makes a straight line is because it increases at a constant rate of 3. Our equation was y equals 3x, so our rate was always 3. Whenever you have something increasing at a constant rate, it's going to create what's called a linear equation, meaning it's going to make a straight line. So whenever you see x to the power of 1, like there's no exponent up here, it's going to make a straight line. For math 6, that's all we deal with. Eventually, like you'll have maybe an x squared up there, and it'll make u shapes and things like that. But for us, we're going to only be dealing with linear equations that make perfectly straight lines. So if when you go to graph some of your points, if you get a point that's like over here, and in order to connect them, you have to go off the line and it makes something else, you did something wrong, because all of our equations should make perfectly straight lines. When you connect all the points, they make a straight line. So again, I hope you heard that and it sunk in. If when you go to graph your points from your table, and if you go to connect them and they don't all connect, if you have to go off your line in order to connect one of your points, double check it. You did something wrong, because all of ours come from linear equations and should therefore make a perfectly straight line, because we're always moving at a constant rate of 3/1. Notice this right here represents the change in y over the change in x. So we always went from point to point, up 1, 2, 3 over 1, up 1, 2, 3 over 1, even from here to here, up 1, 2, 3 over 1. That's what the rate is. It's telling you how much you increase from point to point to point. The change in y over the change in x. It went up 3 and over 1 from point to point. Pretty nifty how it's all like coming together, huh? Okay, so they might ask you, what would you title this graph? So if you have to come up with a title, you want to include everything that gets the gist across. So what is it talking about? It's talking about Susie and Susie's what? Susie's bike ride, okay? Or how far Susie traveled on her bike, okay? Something talking about Susie and what she was doing. That's what we're going to do when they ask you to title the graph. Okay, so we titled it Susie's bike ride. Why did you do that? Because the problem's talking about how far Susie travels on her bike. So I got the gist across. Don't just make up something random. Do it related to the problem. This problem is talking about Susie's bike ride. What would you label the x-axis? Okay, well, the independent variable always goes on the x-axis. And what was the independent variable? It was talking about the time. So I would label this the number of hours or time. And that's what we did earlier. We labeled that across the x-axis. Okay. What would you label the y-axis? Well, the y-axis is always the dependent variable. So since the dependent variable was talking about the distance, I would label it the number of miles or distance. And that's what I labeled along the y-axis. Explain this graph in 1 to 2 sentences. Okay, so how would you explain what's happening in this graph? Okay. Hopefully you wrote something along the lines of, this graph shows that Susie goes 3 miles for every 1 hour that she rides her bike. So notice how I talked about the miles, the hours, and I even used my rate within it. So my rate was 3, so she goes 3 miles for every 1 hour that she rides her bike. That's it. You just are summarizing what happened in the graph. Okay. So I want you guys to go ahead and turn the page to page E11, and it's very, very similar to the problem we just did. See if you can complete it. Okay. So you paused the video, you tried E11 yourself. Now let's see how you did. Now you unpause the video and you're back with us. Okay. So you already tried it, right? The problem says John makes $5 for every magazine that he sells. So that right there is my rate. Okay. Write an equation for how much money he made. Use the variables x and y. Well, y equals, what do you think? If that's my rate, because I saw the word per, each, every, I'm going to multiply that with my x. And does that make sense? Yeah, each time you sell something, you're going to multiply how many you sold times 5, and that'll tell you how much you make, right? I kind of just labeled my independent and dependent variables, didn't I? All right, but let's go ahead and follow and make sure that we fill out everything that they asked me to. They said fill in the chart using the equation above. So I know that which one's x and which one's y. Is it how much money I make depends on how many magazines I sell? Or is it how many magazines I sell depend upon how much money I make? The first way made more sense, huh? So that means how much money I make depends on, this is my dependent variable, depends upon how many magazines I sold. Also, you can use that y per x trick. Y per x. So look at the word per, each, every, and it separates your y from your x. So y is talking about the money made, and x is talking about the number of magazines sold. So this is your independent, this is your dependent. Okay, if you plugged in numbers, let's say you plugged in 0, 1, 2, 3. So if you sell 0 magazines, I'm going to plug it into this equation. 5 times whatever x is. Well, 5 is 0, if 5 is 1, if x is 2, and if x is 3. So multiply 5 times 0, you get 0. Multiply 5 times 1, you get 5. 5 times 2 is 10. 5 times 3 is 15. So in the table, you would put 0 for the independent and 0 for the dependent. 1 for the independent and 5 for the dependent. 2 for the x and 10 for the y. 3 for the x and 15 for the y. This is just my work of how I got it. I substituted in 0, 1, 2, and 3, my x values, into my equation in order to solve for the y. Now I'm going to go ahead and graph this on the chart. So which one's what? Which one tells me up or down? Well, if this is my x, then this is talking about the amount of magazines sold. And this right here is talking about the money made. Now I know what to do. So this tells me the right or left because it's X, and this tells me the up or down because it's Y. They're both positive, so I'm always going to go right and then up. So over nothing, up nothing. Over 1, up 5. Over 2, up 10. Over 3, up 15. Now, when I connect all of those, it should make a perfectly straight line. And if you need to, you can use a ruler or the side of a piece of paper to connect your points. If for some reason when you go to connect your points, one of the points is off, you did something wrong, because these should always come from linear equations. And when it makes a linear equation, what is it called? Linear equation? Linear. It makes a line. So what shape do these points make? It always is going to make a straight line. If it doesn't, go back and relook at your work, okay? How do I know that it makes a straight line? Because it's a linear equation and it increases at a constant rate. It's always from point to point going up 5 over 1. Because remember, the rate tells you the change in y over the change in x. So 5 is 5 over 1. Up 1, 2, 3, 4, 5 over 1. Up 1, 2, 3, 4, 5 over 1. What would you title this graph? Think about it. What's it talking about? So the person is John, and what's John doing? He's selling magazines. Okay, so I would say John's magazine sales. Okay, that's what I would title this graph. John's magazine sales. Now you could also say, John selling magazines, or the money John makes from selling magazines. Something along those lines. You're telling who it is and what they're doing. Okay. What would you label the x-axis? Well, what did we? We labeled it the number of magazines sold. So this is the cause, and what's it affecting? It's affecting the money made. So that would be your dependent. So why do we label these ones? Because y is always the dependent, and how much you make depends upon how much you sold. So how would you explain this graph in 1 to 2 sentences? What's it talking about? Okay, think about it. Now, if you unpaused it and you're back with us, hopefully you mentioned John and what's happening. So John makes $5 each time he sells another magazine. That's what the rate is saying, right? So right there we go. The essential question is how do you do all this? Okay, so from step by step, first thing we want to do is identify the independent and dependent variables. That helps you create an equation. Then you plug in numbers for x to find the corresponding y. Graph those points that you found in your table onto the coordinate plane, and then connect those points to make a straight line. If they don't make a straight line, you did something wrong, because all the equations that we're dealing with are linear equations. Okay. And then when they ask you to label the axes, they're not saying, hey, label this X and label this Y. We know that. We want to know what's the X-axis talking about, the number of magazines sold. What's the Y-axis talking about, the money made. And when they ask you to title the graph, get the gist of what's happening. Talk about the subject. So who is doing what? And that's all there is to it. So hopefully now you can see how it all comes together. Okay. Independent and dependent variables help you define which one's X and which one's Y. And then from those tables, those represent coordinate points on your graph. And how you can check yourself is once you connect them, they should make a perfectly straight line. And if they do, you did it right. Congratulations, you just mastered a very, very difficult concept.